Okay, hello everyone, my name is Josh. I will be doing the kind of intro video to our behavior tree repository, and I'll kind of walk through the structure of the nodes. I'll show you a little diagram and talk about some of the coding standards, kind of how we set it all up, and how you should try and follow what we've done. So to begin with, we're using GitLab. We have our own repo. It's supposed to be basically a standalone repository that you can use for any sort of mission or whatever in the future. So it's all in C++. It's in the same NUAV group. So the README, the only real setup you need is to recurse the modules when you clone it, so you can get the gtest stuff. Other than that, some coding practices that we do. We're trying to follow Google C++ and basic C++ style guides. We use CLion mainly. It just has a nice interface, and we use the default CLion C++ settings. Other than that, yes, we also try to have some good documentation for our code. Right now, we don't have an actual thing that generates documentation, but it could be in the future. Basically Java doc style, so it's in the headers, which you'll see. Here's just some examples of very specific things that we do. And then the general workflow is we'll create issues in this issue list here. So for each issue, you can just make a branch, create a branch that will just name it that issue. So you work on that branch, make sure whatever you do, you test it and it fully works, and then you can create a merge request, and we'll review your code and make sure everything works the way it's supposed to work. So yeah, you just work on your issue, make a branch, and then we will push it all to master. And other than that, Cameron's already talked about kind of the theory behind all the different nodes, so I'll actually show the diagram of the structure using this program called SourceTrail, which is pretty nice. So it shows the whole inheritance structure and even some code snippets on the right there. So we have an abstract node sitting at the top, which just is the template, basically abstract node. So it has a tick and a abort, a toString, and access to a blackboard pointer, which is a shared pointer. And then it has a current status and obviously the shared pointer of the blackboard. So every node is derived from this class. So the basic abstraction below that is control node, leaf node, decorator node. Control node only they can have many children. It's basically the only thing that differentiates between a leaf node has no children and a decorator node has one child. So if we click on an example of this, we have functions for adding children, and then we implement the abort and set blackboard based on what a control node needs to do. So for abort, it needs to abort all of its children. We have that as a protected function, and it contains a vector of a node pointers to its children. And if we want to look at a specific a node or control node, we can look at the selector node. Basically, selector node has its children and overrides tick. And if we look at tick, it'll loop through all its children and basically perform exactly what it needs to do. So just like it says it here in the header file, calls tick on each of its children until one returns success. Once it returns success, it will abort the other children and return success. So basically all of the code nodes that we have been tested. I'll go into that later, to perform the function that they're supposed to perform. So we have memory sequential, parallel, reactive sequential, we're hoping to get some good documentation on these definitions, but for now, the header files show a pretty good idea of what they do, or you can Google it. We have decorator nodes, which is the last type, which have a single child, so that child is the only one it's responsible for when it ticks. So we'll have inverter node, repeater node, retry node, and then an always return, which currently we have always succeed or always fail, which is a type of always return. Yeah, there should be one other type in the works that basically will check a condition and keep taking that until the condition has been met. I think it's going to be called the while node, so while that condition is false or true. Now, the very important things, they're kind of the what tie into the ROS part of the RO workspace, or the action and condition nodes. So these are actually pretty much unimplemented, which leave a tick as virtual. So I click on condition node. Basically, this tick is not implemented anywhere, and that's what we inherit from this condition node. And so if we want to do a condition like we're flying to a certain altitude, we inherit from that, and then in our ROS workspace, we'll check the altitude, we'll override the tick, check the altitude, and then return success or failure based on that. So the point of these are to be open-ended. Same thing with an action node. An action would be to go to a waypoint, and in that, like, we don't implement that in this library. That's implemented in the RO workspace outside of this. So we have, threaded action nodes, basically, so they run on separate threads, so not to interfere with the ticks of this behavior tree, or whatever behavior tree we have. I can go into actual CLine now and show some of the testing. The basic test right here is for G-test. We'll use the test F kind of test. Basically, you have a setup. So if you're used to Java, this is like the before, where you set up, okay, we want 2 action nodes and a parallel node, and you instantiate them, and then you call that. So this is called the parallel node test. So that should be probably down here, parallel node test. So, and then you give specific tests. We are testing, in this case, if the status ends in success here, and then this is a fail. So every time you put that struct in there, it knows to call that as before, and then you name it, and then you run the test, and then always at the end you want to assert something to actually test it. And basically you use the before, so you can make multiple setups just to make this testing a little bit simpler. And we use CLine. It's very nice. You can just hit the play button and run the test, and it should pass. If it doesn't, then you know you did something wrong. Other things that are important that aren't in that tree are we have specific implemented action test nodes and condition test nodes. So these basically you can check how many times they were here. Let's go into it. Let's go into this. So yeah, we have a tick count and abort count, and we can set the return status of that. So this is all for debugging purposes. Basically, we can just see what's going on in there without actually running a ROS action. Other than that, we have BT runner, which kind of encapsulates what a tree is, behavior tree, and lets us run it easily from the outside. So it basically just contains a reference to the root, and you can also set a threshold, but interval where the ticks are happening. So all it does is handle the threading and the ticking of the root and whole tree when you run it right here. The other important thing is the blackboard. The blackboard is kind of just a very abstract map where we can hold any type of, like, any key and any value. So we're using C++ 17 in the standard template library any. It's kind of like a template, but it just allows you to put any object in there and it's type safe. So you can look that up more on your own, but basically we have this all text up so it's safe, and then we have this unordered map of storage with a string, key, and any value. Kind of like Python dictionaries, they're all type safe, so that's kind of what we do here. And basically every node has access to this in a shared pointer, so you can share information across. Cameron probably went into more detail about what a blackboard is. Let's see, what else is important here? Yeah, you can just see we have abstract nodes set up in the abstract node.h. So you have a node, control node, decorator, and leaf. And then within those, we have the specific implementations in control nodes.h, decorator nodes.h, etc. And always make sure to make your own tests for whatever nodes you create. And that's basically a good intro to the whole paper tree repository. Thanks for watching.